Welcome to EDU World Space.
One of the clusters in atomic physics that's very useful is the product of h, which is Planck's constant, and the speed of light. So h is 6.63 times 10 to the minus 34 joule seconds in SI units. And c is, of course, the speed of light. And let's write that down in meters per second. Because what we would like to do with this cluster of quantities is to make it useful in the energy of a photon relationship. So what we would like to have is the energy of the photon in electron volts. And we would like to be able to calculate the wavelength in nanometers, which is 10 to the minus 9 meters. So let's go ahead and convert the h and the c, and you'll see that it's a very easy number to remember. So the first thing that we'll do is we'll take h and we will multiply it by 1 eV per corresponding number in joules. And that is 1 eV in basically the electron charge, or E, in terms of turning it into joules. And if we multiply that out, that comes out to be 4.14 times 10 to the minus 15 eV times seconds. So we've gotten rid of the joules there. What we're going to do with the speed of light is we will simply convert it into nanometers per second instead of meters per second. And to do that, you want to multiply by 10 to the 9th nanometers per meter. So nanometer is a little tiny unit, which is useful for atomic physics. Okay, and that is easy. You just get a different power. And then if you multiply this new set of units, h times c, so that's the 4.14 times 10 to the minus 15 eV times seconds. Yeah, the seconds will cancel. So you're taking two numbers with some rather awkward exponents, maybe exponents that are a little bit harder to remember, and you are getting them to a number that is quite easy to remember, 1240. And like I said, one of the most useful things to do with that cluster is to calculate the wavelength of a photon, given its energy in electron volts.